You take lung cells and grow them up and pull the exosomes off it that they have secreted and put it into your body intravenously, it's going to the lung tissue. It's not going to work elsewhere. Same for heart, same for liver. Most of the cells in our body are very specific to their own exosomes. Exosomes weren't even identified until the 1980s, and it wasn't because there was somebody super smart. They just didn't have the technology. They didn't have the electron microscope until the 1980s in order to see something that small. So they were able to see the cell and start to see cell function, and they saw the cell creating little packets inside there, and every once in a while, it would spit out a packet. And they went, oh my gosh, these cells are so efficient, they take out their own garbage. And that was pretty much the belief for a long period of time. They were just removing the metabolic waste from the cell and taking care of it. Well, move forward to the early 2000s with the identification of luminescent nanoparticle tracking analysis. Now they could look at it, and they were able to look at what's in these little bags of garbage, and they weren't garbage. They were truly what they call now packets of biocargo, which was explained beautifully earlier. All the things in this biocargo that they originally called a secretome, some people call it conditioned media, we become to know it as an exosome. They've identified more than 700 different types of proteins associated with exosomes. Obviously, the growth factors, the immunomodulatory cytokines, of course, when they come from a specific cell site, and of course the nucleic acids, and we'll talk about those briefly also. Without these secretions, quote, exosomes, the cells don't survive. Just like if we can't communicate, we probably also would not survive. So what's an exosome? Virtually every cell in our body secretes an exosome, and they're fairly specific to the type of cell. You take lung cells and grow them up and pull the exosomes off it that they have secreted and put it into your body intravenously, it's going to the lung tissue. It's not going to work elsewhere. Same for heart, same for liver. Most of the cells in our body are very specific to their own exosomes. What we will talk about here are eukaryotic cells. You know, there are prokaryotic and eukaryotic. We'll talk about eukaryotic cells that contain a nucleus. So what the nucleus does, it's going to monitor both the intercellular and the extracellular components around it, in that paracrine space around it. So the nucleus inside the cell, on a daily basis, our cells fall out of homeostasis thousands to 10,000s of times a day, just through regular to the cell wall, and will break open internally, release that component internally, and the inside of the cell is back in balance. It's back in homeostasis.